Hey there, 6th grade. Today we're talking about two-step equations. So you got to hear the story today finally and learn about Meg and how good she is at solving two-step equations and solving equations in general. So now we're going to see just exactly what she taught me. So she's going to teach it to you guys too. So here we go. Get this homework sheet ready to go, title and date and name at the top. Now, before we get to some notes, I want to show you just why is it that Meg is so good at solving equations. And here's the reason. Right now we could see that, like usual, we had the scales, and this is demonstrating to us what an equation might look like if we don't know what is inside these x boxes. If we don't know what the value of these x boxes is, well, we know that what has been done to one of these x boxes, what is with it that we need to undo in order to find out what it balances with? Well, it's been doubled or multiplied by 2, and it's also had 3 added with it. So we know there's multiplication and addition. Now, why can't you just undo this in any order? Well, let's think about it. Well, if we tried to undo the multiplication first, we'd have to split it into 2 groups. But we can see that these 3 don't split into 2 groups very nicely. And so that's one of the reasons that Meg is so good at undoing equations and solving equations. And you could see that instead Meg is going to say start by undoing the addition, and that's really easy to do. So that works out well. The other reason is just in general the order of operations. That's the order in which we combine numbers, the order in which we perform operations to simplify an expression. But with a two-step equation, what we're trying to do is we're not trying to combine things, we're trying to undo that combination, because we need to, instead of putting things together, we need to get things away from that variable so we see what it balances with, so we see what it's equal to, so we solve for that variable. And so that's why we're going to kind of undo things. We're going to do it in the opposite order of the order of operations. So we're not combining this variable that we don't know. We can't combine it with other values. So what we need to do is undo all those operations in the opposite order. And some of you figured out that Meg is actually just Gemma backwards. So Meg will undo the operations when solving equations, just like Gemma was good at putting numbers together. Here are the notes you need today. It's just that Gemma is great at combining values, and we'll also say simplifying expressions. So that's what we need to know, is that combining values and simplifying expressions, because that's what we're doing when we're performing the order of operations most often. What you've seen so far is you're just simplifying an expression. They're writing out a number in a really long way, and you're going to perform those operations. Meg is great at undoing things and solving equations. So if you're trying to figure out how to undo what's been done to a variable, Meg is going to tell you the way to do it. So what I'd like you to do is I'd like you to draw this example with me. We're going to make it a little different. Let's make it look like this. And we'll say, okay, what equation do we have here? Well, on the left-hand side of the scales of justice, we have 2 x's, or 2 times x. And we also have 4 that have been added to it. And then on the right, we have 12. Now, again, I said that Meg is going to tell us the order in which to undo things from both sides. So we see that we have multiplication that's been done to the variable. We also have addition and subtraction from left to right. So Meg is going to say undo the addition and subtraction from left to right. Well, how do I undo addition of 4? By subtracting 4. Again, these inverse operations, adding 4 then subtracting 4, cancel out. Now we have 2 times x, 2 times the number, is going to be equal to 8. So what's that number going to be? Well, you can probably see right away, or you could think, so 2 times the number is 8, what's that number? It's 4. Or you could just say, what's being done multiplication, how do you undo that? By dividing both sides by 2. Those inverse operations cancel each other out. We get the answer of 4, just like I said. What would that look like as we're going through this step-by-step process? Well, we could delete 4 from both sides. We could subtract 4. That's what we did. And then we split this into 2 groups to see, okay, if we have this still balanced, I can take away half the weight on the left. If I take away half of the value on the right, x will balance with just 4. So there we go. Oh. And that was the first example. If you didn't write that down, I'm going to make you rewind and draw that example and write it down as well. You should have been doing that one with me because we had example 1 at the top, so you have to do it. I'm so sorry. But join us on the next 2. And here they are. Examples number 2 and 3. Example number 2 says 3m plus 39 equals 75. Okay, so again, we're going to solve for that variable. That variable is m. We don't know what that value is, but we're going to figure it out. Meg is going to tell us how to do it because we're going to be undoing operations, and she's great at solving equations. So first step would be to draw the scales of justice. Second step is locate the variable, it's m, and third step is to undo what's been done. Well, there's addition and multiplication again, so we're going to undo the addition first by subtracting 39 from both sides. We'll just, those cancel out, so I'll cross them out so I remember. 3 times m is going to be equal to 36. What number times 3 equals 36? That's kind of what we're asking ourselves here. And to figure that out, we have to know our fact families and undo that. We'll figure out that m is equal to 12. So that one's easy enough. We could check it by plugging it back in. If we plug in 12 for m, then we're just going to be putting these together. We'll be combining these values and following Gemma. Gemma would say 3 times 12. We do multiplication first when you're combining values. That'd be 36. 36 plus 39 is 75. We're good. Let's look at number 3. This one's a little trickier. We say we'll draw the scales of justice. We'll locate our variable. It's g, and isolate the variable by undoing what's been done in the correct order. Now, what you need to know here is that we actually don't just have addition and division. We have grouping. So that's why I made such a big deal about having you guys remember grouping symbols. The top is grouped together, and so is the bottom. So we undo grouping last. So whatever has been grouped, g plus 17, that's undone last. So we're actually going to undo division by 6 before we undo that plus 17. So I'll multiply both sides by 6 to get rid of this division by 6. Those inverse operations cancel out. On the left-hand side, we have g plus 17. And I need to do 6 times 34. We can do this mentally. We'll say 6 times 4 is 24. Carry a 2. 6 times 3 is 18 plus 2 is 20. So g plus 17 is 204. I need to undo addition by subtracting. We're almost home. G will then be equal to, oh, we have to cancel out here. We'll have g is equal to 187. So there we go. This is the work you need to show for these 2 problems. Hopefully that process makes sense. Again, a Meg is going to tell us the order in which to undo things, but it's just same solving equation steps. I'm going to leave you with 2 problems. First one is 2m minus 37 equals 55. Second one, x over 3, or x divided by 3, plus 31 and 5/10 equals 67 and 2/100. Remember your decimal rules, and best of luck. I will catch you later.